Yes, we are recording. All right, so this is actually pretty easy. We're talking about graphing dilations. And can somebody tell me what do you need in order to create the image of a dilation? Well, of course we have the pre-image, but you need something, right?
The original coordinates.
Okay, the original coordinates. What else? The what? The command. Okay, what do we call that? The scale factor, right? The scale. What does the scale factor do? What does it ask us to do?
Tells you how much text.
All right. I thought he called you. I'll bring him back in. All right. So we need the scale factor, right? What do we need the scale factor for?
To know how much to increase or decrease.
Yes. So yes. Good job, Jennifer. Yes, the scale factor tells you how much it's gonna enlarge or shrink, right? So for example, here the rule is literally multiplying each of them by the scale factor. Ugh. I know what I'm gonna do because I don't like this thing, so I'm gonna take it to the other side. That's not y'all's. No. Yeah.
Remember when you said they were going backwards?
This stuff is like stupid sometimes. Look at it.
You're a boy. I want the
Okay, so as you notice here, that's the rule. If that's the rule, then we can assume that the scale factor is 3, right? That means we're multiplying each of the coordinates by 3 to get the new image, or to get the image from the pre-image. So what I would suggest you do, first of all, is to pay attention, and second is to get the coordinates. So the coordinates will be right here. And we're talking about each point, right? Wherever the points meet, that'll be a coordinate. So we have 2 and 2, which is this one right here. And then the next one I would say is -1 and 2. And then we have -2. -1 and 2, -1 and 1, -2 and 1, -2 and -2, negative, no, that's 1 and -2, and then 1 and -2, no, -1. And the last one is 2 and -1, right? A way of doing this simpler is just to say multiply each and every one of those values by the scale factor, and that gives you the image. That's it. That's a very simple way, right? So I will give you a couple of seconds. All right. So let's get the new coordinates. All right. So if we multiply that by 3, -1 times 3 is -3, and then that'll be 6, right? This is -3 and 3. This is -6 and 3. This is -6 and -6. This is 3 and -6. And now all you have to do is plot it, right? You go over here and plot it. So -3 and 6 would be -3 and 6 right there. -3 and 3 right there. And then -6 and 3 right there. And then -6 and 6 right over here. And then 3 and -6. And then 3 and -3. And then 6 and -3. I'm missing 1 point. That one? 6 and 6, right? So I can easily come over here and plot my little points. Well, I already plotted. I just need to connect them, right? There we go. Now we have the dilation of the shape. It's just a reminder, when you dilating by a number that is like a whole number or bigger, it's growing. The new image will be bigger. If the scale factor is a fraction, that means it's gonna shrink. Do not forget that. Do you really need to go that bad? Kind of, and yes, yes. Go. I do. Hang on a second. Okay, so now that we understand that, we notice that we can multiply the coordinates by the scale factor and get the image, right? What is another way to get the image? Just by looking at them. What can you tell about the image and the pre-image? They're the same shape. What else? The one is bigger, right? Same angles. Yeah, they don't change. Yeah, I can just extend, right? What can you tell about the side though, the measurements? By what? Not by 3. They're times 3, right? So this one right here, it's 3. And when you use the scale factor, it becomes 9. So you're basically multiplying it by 3. This is very important for the next section, which is going to be similarity. You're going to have a shape that is small and one that is bigger. And they might be in different order, but they're going to ask you what is the scale factor. And you need to know that in order to find the missing measurements. Remember that for whenever you dilate shapes, they all increase at the same time, proportionally. Do not forget that. Well, the scale factor is 3. We already answered that. And we answer that, and we answer that. So let's move on to the next part. Well, we already answered that too, and that too. On your paper, let's do that one on your own. I'll give you a couple of minutes to finish it. All right. I can write on this. Cool. So what we're gonna do on this part is basically try to find the coordinates for each of them, right? The coordinates are on the vertex of each of these, right? So let's find the first one, which is the top. It is a 0 and 5. Then this one right here is -4 and 2. And then -2 and 2. -2 and -4. And then 2 and -4. And then 2 and 2. All right. And I just said, very simple. Look over here. Don't should be confused. All you have to do is multiply each and every one of these by half. And you get the new coordinates. And you're like, I don't know how that works. Well, let's try it. What is 0 times half? 0. Please excuse that comment. Um, when you multiply 5 times a fraction, when you multiply a number, any whole number by a fraction, you're actually reducing that number instead of increasing it. So watch what happens here. Multiply 5 times 1 is 5. Bring down the 2. And then see how many times 2 goes into 5? So it's 2.5, right? So 2.5 or 2.5, it will both work. Then you multiply -4 times half. What do you get? -2. And then 2 times half? 1. If I tell you one thing, when you multiply by half, you're literally cutting every value in half. That's all you're doing. So this one will give me -1 and 1. This will give me -1 and -2. This is 1 and -2. And this is 1 and 1. And 2 and 1. Once you find the pattern that you realize you actually just cutting them all in half because you multiply them by half, then it's easy. And now we can plot them. 0 and 2.5 right there. Then negative 2 and 1's right here. Then negative 1 and 1's right there. Yes. And then negative 1, negative 1 and negative 2 right there. Is that right? This one? Where it's supposed to be? Oh, it's up. It's right here. Oh, I got lost. Okay. And then negative 1 and 2, right? And then 1 and 2. And then 1 and 1. And then 2 and 1. So now you have the perfect dilation. There you go. So again, when your scale factor is a fraction, you're actually shrinking the shape. When the scale factor is a whole number or larger, then it's going to expand the shape. Do not forget that. Now tell me, can you call two congruent shapes similar? Why? What does it have to be similar?
Same angle.
That's it, right? Same angles and same shape. If they're congruent, meaning they're exactly the same, then they're also similar, right? Good. And what will be the scale factor then? 1, right? 1, because you're multiplying everything by 1, which gives you the same thing. Ah, good job, Tabari. She and I sleep all the time. All right, on this one is to show you the center of dilation. This means the following, that, for example, on this one, the center of dilation was in the middle and the shape was around the middle, meaning it covered all quadrants. So the shape looks like it decreased, right? On the one on top, it looks like it got bigger. Well, where'd it go? Oh, it was over here. Yeah. It got bigger, right? Because the shape, if you notice, it was occupying all 4 quadrants. But when the shape only occupies 1 quadrant, it doesn't necessarily stick to the middle. That means the shape might end up outside of the other shape. Like in this situation, when you plot it, look where it lands. It lands outside in the same quadrant, but outside, which is perfectly normal. Because if, notice A, the coordinates for A is 1 and 1, right? If the scale factor is 3, the multiply 1 by 3, what do you get? 3. And the other one? So you go to 3 and 3, and you end up with A prime outside of the shape. This is perfectly normal. Do not forget that. Don't think that dilations means that the shape has to be either outside or inside the other shape. It could be somewhere else. A good way that I do this usually when I want to measure the dilation and see if it works, or if I did it correctly, is by doing the following. If I grab this and the center of dilation is literally the origin, then when I do this, it should cross all the points. You notice A prime right here. I mean, A and A prime are basically on the same route, correct? See? It's crossed by the same line that comes from the origin. That means C and C prime should also be on the same line. And they are. And that means that B and B prime should also be on the same line. And it should always be that way because it's exactly like the way that I show you this with the projector. That whenever I walk forward, the image gets shorter and shorter proportionally. Imagine there's a line coming out of the side and a line coming out of the side. It basically measures that. It makes sure that everything is expanded proportionally. And that's what it does here. Imagine that the 0 point, the origin, is your light of the projector, and it's basically making this shape smaller or larger in that direction. That's a good way to check if your answer is correct. You can grab your pencil and just trace it. So, given that information, go ahead and work on number 5 at the bottom of the next page and do the dilation for that one. Yes. All right, we're back. So, let's start with the first point, which is x. What is the coordinate for x? 3 and 3, right? And what is their scale factor? 1/3. That means I'm gonna cut those in thirds, right? Or multiply it by thirds. So 3 times 1/3 equals 3/3, which gives me 1, right? So my image is gonna be 1 and 1. If you don't get how I did this, please go back to fractions. All right? You're just multiplying this and then divide by the bottom. So that means x prime should be 1 and 1. And then y prime is 9 and 9, right? So it'll be 3 and 3 because you multiply 9 times 1/3. That's 9/3, which gives me 3, right? So it'll be 3 and 3 right here. And z prime is 3 and 9, which will give me 1 and 3. And now you have the new shape. Oops. There you go. Now, I want you to understand that the images don't always have to touch. Like right there, they touch where the y prime is and the x is, but they don't necessarily have to do that. Notice that the one on top do not touch at all. This one right here, they do not touch. And they don't have to be in the same path. They don't have to be the same neighborhood. But if I grab my little line, obviously this one is going to be a straight line through both of these points. And this one right here should go straight through that one too. With your pencil, you can do that. All right, moving on. Let's do this one on your own. Yes, you do have homework, but not yet. No, your homework is actually the next page, the one that Jennifer just said not to be it. This is it.
You gave that to us.
That's what I gave it to. No, I didn't.
I have it.
Well, I'm glad that you're honest.
We already did that.
You didn't turn it in though.
That was hard. I didn't get it.
Oh, there you go. I give it to you Friday, and that means I have not picked it up, which you should have done by now. But I will allow you because I just gave it to the first period. Hey, I just gave it to my first period. If you didn't do it over the weekend, Jennifer, then you have one more day to finish it.
I didn't do like homework. I didn't.
Well, now you should be able to, now that we went over the stuff. So go ahead and do that on your own. You can tear it out. And then once you're done, obviously it's already in your possession.
You remember I ripped the page in half?
I am old.
Oh yeah, she like ripped half.
So let's work on this one. Can't wait all day. Let's do this. So this is 2 and 2, and then 0 and 2. This is -2 and 0, and that's negative. It's 0 and -2, and then 0 and 2, right? And the scale factor is 3/2, right? So 2 times 3 is 6 divided by 2. 3, negative, and 0. And then you get 0 and the same thing, -3. And you get 0 and 3, right? So let's go plot it. 3 and 0 right there. And then -3 and 0. And then 0 and -3. And then 0 and 3. There you go. And you end up with this nice little dilation. Dilation. All right, the next one should be quite similar. The scale factor is 1.5. So let's multiply 2 times 1.5, and what do you get? 3.1. 3.1? 2 times 1.5. You get 3, right? So that means it'll be 3 and 3 right here. And the other one is 5. 5 times 1.5, what do you get? 7.5 and 3 right here. Yep. And then the h, what is it? It should be right there. And then this one should be right here, correct? So you get another dilation that is a little bit off the grid, but I mean the lines of the grid, but it still works. And the last one is getting smaller because you're multiplying by a fraction. So where do you land with the A? Then you land like right here. There we go. This isn't necessarily difficult. It's just dilations. Tomorrow we're gonna go over similarity and your homework. Yes. Uh, your homework I already told you is this page. See ya tomorrow.